Hello students, and welcome back to the second part of inverse trigonometric functions from sort of third classes. We'll be continuing where we left off, that is from the graph of cot inverse x. That's right. Alright, so this is cot inverse x. This is point number 1. Cot inverse x is an even function, therefore it is symmetric about the y-axis. Okay. Point number 2 is the domain and range as before, so it is defined for all y belonging to 0 open to pi open. Pi is actually 0 open to pi open, and x belongs to R is the range set. Now you can easily say that this is an even function because it is symmetric about the y-axis and it is pivoted. This is the pivot at pi by 2, and that's just about it for cot inverse x. Let me tell you a bit about the map of 1 by sine inverse x, or rather, okay, this is sec inverse x. Let me just write it down. So this is sec inverse x. Now the value of sec inverse x, now how can you distinguish between cos inverse x and sec inverse x and cosec inverse x? They almost look similar. Let's show you how cosec inverse x looks like. This is how cosec inverse x looks like. Right, so the trick to determining which is which, they almost look similar, is first of all the values. And even though if you don't know the values, or even if you are missing out the values, you can easily say that this is the graph of sec inverse x, because this is an even function. This is an even function, and this is an even function, and you can say this because it is symmetric about the y-axis. All right, so how do we determine if this is even or not? Because cos inverse x is even, so 1 by 1 by sec inverse should be even. Now how do I determine if cos inverse x is even? We say that cos x is even. Cos x is even, and so cos inverse x, the inverse of an even function, is always even. The inverse of an even function is always even. So cos inverse x is even, and therefore sec inverse x is even. Okay, so let's just write this down somewhere if we have space, or I'll have to rub this out. Let me just rub it very quickly. Okay, now point number 1 to be noted is that sec inverse x is an even function, and hence it is symmetric about the y-axis, and the second part is the value of the domain, the domain and range set. So sec inverse x is defined for all y belonging to 0 closed to pi by 2 open, union pi by 2 to pi closed. Alright, so this is y and domain and range. I hope you get this idea how we got here. Alright, so we'll move on. This is the graph of cosec inverse x, as we can say, because it's an even function. How do we know it's an even function? Because 1 by sine inverse x is even. And how do we know if 1 by sine inverse x is even? Hell, how do we know if sine inverse x is even? Because we know that sine inverse or sine x is even. Alright, and as before, sine inverse x is odd. Sine inverse x is odd. So sine x should be odd. Sine x should be odd. Alright. So, and obviously you can say this, how this is even or how this is odd. Alright. So first things first, we'll define by the symmetry what we observe. So cosec inverse x is an odd function and is symmetric about the y-axis, and the second point should be the domain and range, the characteristics of the domain and range, which is, this is defined for all y belonging to minus pi by 2 to 0 union 0 to minus pi by 2. Now even after this, if you cannot determine what is the inverse, what's the inverse of a function's graph look like, let's say if we have fx as a function, so we have to find f inverse x like so. We know that cos x looks somewhat we know how cos x looks like, and now we know how cos inverse x looks like. So how do we if you don't know anything, then how can, and you only know how this graph looks like, so how do you draw this graph? This is a trick I'm telling you. The trick is the graph of f inverse x. I'll just write it down roughly. The graph of f inverse x is the reflection of fx along y equals to x. So y equals to x acts as a mirror, and f inverse x is a reflection of fx reflected on y equals x. That's it for now. We'll continue in the next video. Thank you for watching.